consultancy. Please talk to Shabin, there in the back. You can see him, he's raising his hand. Or to Mohammed. They have the really nice iPads and they will fill out the form for you. And that way we can get your details and we can set up an appointment in case you want to talk further about Couchbase, in case you're interested about using Couchbase in your companies. So please let us know. The team at Interkey, who is representing Couchbase here in the Kingdom, is really glad to help you out. We have full support for Couchbase and we will provide training in the future. So please make sure to register, and also please make sure to register in the link that we provided in the videos, so that way we can get your certificates of attendance. Yes? Now we will introduce Cesar Lopez. He is our consultant from Datum.com. MIT 35 Award. He has co-founded over half a dozen technology companies in data analysis and data science related technologies. At the international level, he has founded and managed Total Comtech in Ecuador, a technology advisory company for governments. He has also co-founded Pergamino DB, a data analysis company in Las Vegas, Nevada. Mr. Lopez was recognized with the 2012 Columbia MIT TR35 Award for his work on data sensors on UAV platforms. His team has coordinated over 8,000 UAV sensor flights for over 30 different locations in Latin America. He was also a winner of Accenture's Award for Innovation, as well as a recipient of Colombia's 2010 Innova Award, recognized by Presidential Decree for having created Colombia's most innovative company. He currently serves as CEO of Datum.com, a big data analytics firm based in Dubai, United Arab Emirates. Please welcome him.
So the Colombian thing actually explains the accent. Thank you, Camille, for that introduction. So we are partners with Interkey, also with CMK, and we also are users, active users of Couchbase. But right now, I'm going to cover a little bit Couchbase, but more in the AI sector. And what I mean by AI is specifically deep learning networks, which is the particular area of AI that creates most interest. And it's also the area that creates more possibilities of what you do with data. Now, by the end of this presentation, I expect that you will have the capacity at looking at governmental processes, but also organizational processes. And you're going to be able to see them and understand which of them are actually applicable for AI and which of them are not applicable for AI. Because as you guys know, definition of AI is a little bit blurry. There's a lot of media out there. There's a lot of badly defined definitions. There's a lot of companies and governments stating that A, B, or C are AI systems, and those of us who have worked with machine learning and deep learning technologies, we immediately recognize them as not such. So there's a certain amount of warning that we're issuing here. It has to do that with the fact that there's a lot of fake data on artificial intelligence and what it is. This is something that all AI engineers have to cope with. It's also fake eye everywhere. This is direct responsibility of the media, but also lack of understanding, including within some computer scientists. You also have some systems that are sold by AI, but aren't actually AI. So we have to be very wary and beware of false arguments. And what I want to do today is uncover a series of clarities on how to build an AI system, and how to actually inventory the potential of an AI system without putting in some of the noise. So you're not going to see any commercial pitch from my side. We're just going to try to state the facts as we know them as data science engineers that we are and AI specialists that we are. If there's anything that I want you guys to keep today, I want you guys to keep one fundamental fact that cannot be ignored. AI is going to fundamentally change how governments, organizations, and companies work. And these changes are going to come much sooner than most of us think. Now, because of the public perception of AI, a lot of people don't know how much AI is already impacting our daily lives. And the seal of a very good AI implementation system is an AI that you don't actually notice that it's working. Kind of like the front page of Amazon, or the front page of the system regarding Uber, Kareem, and this type of systems. These are AI systems that are so efficient that it's hard to tell that they're actually there. So the contention is the real AI that's going to affect us is not the AI represented in a robot with Saudi citizenship called Sophia. It's going to be much more, not explicit, let's call it that way, much more delicate. So let's take a look at this. Again, AI is coming, and some people are not paying attention to it, but it's a fact. And whoever's working in computer science has to absolutely pay attention to it. So the question here is, are you guys paying attention to it? Come on, yeah, okay. How does it? Maybe? Yeah, okay. Good. Awesome. So, really quickly, I'm going to tell you, this is just going to take 10 seconds, I'm going to tell you something about what we do at Data.com. Basically, we have two sources of business. We teach software how to do stuff, and we teach organizations how to empower AI. Most of our customers are actually system integrators, not the end customer. So we actually will provide to programmers, we will provide to system integrators the capacity in AI. Sometimes we will co-build, sometimes we participate in mega projects. But we also provide everything from consulting, training, the whole thing. We've been in Saudi about 14 months now. It's been a very successful operation for us. Now, really quickly, just to give you an idea of the type of systems that we build, I'm going to go ahead and boot up our network. Bear with me for a second. Let's see if it works. I'm just booting up computer vision neural network, and apparently it works. So this is a typical computer vision system that we tend to build. Everything we do, everything we build is custom trained AI systems. Most of our products are not, products off the shelf. We talk to our customers and they will tell us something like, okay, we need to recognize specific items. And then we're basically teachers to the algorithm. So those of you who have interacted with AI before know that sooner or later, programmers are going to look more like psychologists and teachers than actually guys who are writing anything else. And that's actually what we do. We have guys. So usually we talk to the customer and say, well, okay, I need a system that recognizes, I don't know, ugly ties. And hopefully I can show stuff here. Sorry about that. And then we'll just tag the data for several thousands and so on. Okay? That's basically what we do. By the way, most of what we build, we put it on the open source, especially the algorithms. We have several commits in libraries like Keras and TensorFlow. So we contribute to the open source. But even the stuff that we build, we tend to put into the open source. The one thing we don't put into the open source is the training libraries. What? The training libraries. That's interesting. Why? Why do we keep the training libraries proprietary and we just open up the algorithms? How does that make sense from a business perspective? Who can tell me that? Yeah, but why don't we charge for the algorithm? Well, we want to encourage community. But here's the reality of AI. It used to be that it's one thing. and data was just an annex to the algorithm, right? Now data is everything. I can have the same algorithm that you have, but if my training library is better and it's bigger, it's going to do much better because I've been able to teach the system that. So that's absolutely critical. So coming back to what we do, we teach software to do stuff. And we do this using several tools, including neural networks, which is a framework, statistical inferences. We build scalable data engines, and we're happy to say that lately it's basically all Caltrace because, guys, it is beautiful. The second you try it, it is really a big deal. Data mining, we build intuitive dashboards for executives and well. So let's get to the subject and matter related to the utilization of AI to improve government services, which is most of my personal experience, but we also deal with organizations and the rest of it. So here's 4 things that you absolutely need to know as it relates to AI. Number 1 is that the AI boom is absolutely sustainable and should not be ignored. If you're a DBA, if you're a data scientist, if you're a data analyst, if you're a programmer, if you're a person who's making decisions, you're either get into AI or you get out of the way because you will be replaced. It's a fact. Number 2 is the clarity that AI is being used, is effectively being used today in organizations, but with a very limited scope. It's very important. There is no such thing as general artificial intelligence. There is specific intelligence for specific problems, but there is no such thing as a general artificial intelligence. Major misunderstandings that people have, and frankly, companies like, I shouldn't say, they pitch it as a system that does everything, and it doesn't. It's really independent neural networks or independent systems that do specific stuff, and maybe they coordinate it, but it's not one. So it shouldn't be sold as one. So an algorithm that is able to beat the best Go player out there, AlphaGo, is not going to be a chess player. So you do computer vision, like the one, it's not going to do analytics of derivative financial data. So it's a different type of beast, different type of data that is processed in every one. But if you keep the limited scope, you can do quite amazing stuff, actually. So AI is absolutely ready for deployment on very selective activities. And again, if there's anything I want you guys to take out of this particular presentation, tomorrow we're going to discuss infrastructure and a whole bunch of other stuff, is I want you to be able to recognize instantly what applies to AI and what doesn't apply to AI, because that's going to save everybody quite a bit of time. And number 4 is that the adoption of AI is really it's about much more than just technical feasibility. So let's cover number 1, refers to the AI boom is sustainable and should not be ignored. So machine learning algorithms and deep learning algorithms have been around for almost 30 years, but barely in the last 5 or 6 years, they're actually doing something interesting. They are beating humans in tasks like image recognition. They're beating humans in tasks like voice-to-text translation, but also in complex games such as Go, chess. That's like so last century. That's been there, done that. And Go. And so, sorry? And Go. Yeah. Yeah. Okay. Yeah. I'll comment that in a bit. But yes. But the standard for AI has to be that it should be humans. That's like the general criteria. So right now, for instance, we have a computer vision system that is meant for the border, the causeway between Daman and Bahrain, and the task that it has in hand is identifying vehicles without using license plate recognition. And what we've been able to prove is that our results are better than any human just staring at the camera. They're not perfect, but they're better. That's what we're looking for. But why does this happen? This happens for 3 particular reasons that you need to understand. Number 1 is the appearance of new deep learning algorithms. of big data. It turns out that to train an artificial intelligence system, you need huge amount of data, and you need accessibility to that data, which is why we like Couchbase so much, because suddenly the data becomes accessible. And number 3 is GPU power. So GPU power used to be, when I say GPU, I'm talking about the type of thing that you used to buy for games and the graphical processing unit. And it turns out that the training and deployment of neural networks requires large-scale tensor multiplication, which the GPU handles much more than CPU. And this is quite interesting because most data science facilities out there are CPU powered. So it's extremely hard to get cloud for GPU for training. Like barely in the last couple of years, it's actually a thing in Europe and US. Here in KSA, there is 0 GPU power cloud providers, absolutely 0. Maybe we will be one of the first guys to offer that. We'll see what happens in time. But yeah, GPU is a big deal. So I'm going to show you the data now, as it relates to this. First, let's look at the profilation of big data. So a good indicator to be used here is the IP traffic measured in zettabytes per year. There's a couple of data points that are relevant here. First, we know that by 2020, 90% of all workloads will be processed by cloud-based data centers. It could be public or private clouds, but nevertheless, the software will behave in a cloud type of configuration, which means it's scalable. All the characteristics that you will see in Couchbase, but also in other systems. And then the other part of it is that 80% of this data is going to be semi-structured or unstructured, as in not in rows and tables, rows and columns. So, all due respect to Oracle, it's a beautiful system, but whenever I hear somebody saying, I'm doing big data and I'm doing it in Excel and Oracle, I kind of cringe, to be honest. Because one of the important characteristics regarding big data is that the data, by its own nature, is going to be semi-structured or not structured. It's going to come from another variety of sources, and it's going to be transactional by nature. It's going to be interaction by nature. It's not going to be transactional by nature. Let's also look at the deep learning chipset sales. So GPUs are definitely not about gaming anymore. 2016, there were $513 million sold in GPU. By 2022, there is about 12 billion projected. Now we actually looked at for the data in KSA, and we were surprised. Actually, the GPU sales in KSA went up quite a bit over the last couple of years. And we were happy. That means, oh my God, these guys are using deep learning. But then we realized it's not deep learning. It's not gaming. Yep. Yep. Kind of depressing, if you ask me. The good thing is that when those guys crash, we're gonna have a lot of GPUs available. We can also look at the number of annual patents applications for machine learning, and this has gone crazy up. Around 2000, there were the year 2000 was around 100 patents related to machine learning, and by 2018, there's going to be around 5,600. Now, keep in mind that a lot of these patents involve the exact same algorithm. The only thing that changed is the data by which it was trained. That effectively means that the organizations you're working with right now, when you hear the buzzword that data is the new oil, it's absolutely true. But it's the new oil when you have the data available, you can do something with it. You can do some kind of statistical model with it. But if it's just laying there, it's not really worth much. So the second point regarding AI is that it is effectively being used across organizations, but with a limited scope. So organizations of government are and will AI or supervised machine learning that is focused on one task. Right now, the only thing we have available is AI that does one task. Whatever that looks to do several tasks, basically you have to build several neural networks and get them somehow to negotiate between each other and jump from one point and so on. So AI algorithms will be available to use training data to learn how to repetitive tasks. That's like your main target as it relates to AI. And this is, well, this is a fat caricature of me saying what I just said. That broad AI is going to take decades, if it even happens. There were some people that will contain that it might never happen. I'm skeptical. I don't think we're ever going to see general AI, to be honest. But there's other people who have other opinions, and that's absolutely fine. So let's take a look at the current state of this, shall we? We have certain types of cognitive models as it relates to AI. Natural language processing, computer vision, which is what you just saw, pattern recognition, and reasoning and optimization. And you have certain mechanisms to try to achieve something similar to AI. On the left, about 5 years ago, we were working in inference, which were also called expert systems. So the way the expert systems were built is you get an expert in something, and then you put him in front of a coder, and the guy just basically codes whatever the expert knows. And that's like an expert system. But it's not machine learning in the sense that it's not actually learning anything. It's just reproducing whatever the human programmer and whatever the programmer actually, coded. So, but rule-based inference would actually work on stuff like spelling and grammar check. It would actually work on a low risk based on inference rules. You'll be able to say if the person doesn't have a job, don't give them a credit card, this type of thing. It's rule-based. It's an if-then-else type of statement. Then you have supervised learning, which is a little bit where we are. The supervised learning really went mainstream last year. And then you have applications such as voice-to-text detection, facial recognition, scanning of handwriting, fraud detection, forecasting using demand sensing input with learned segmentation, and this type of thing. And you're also starting to see several applications as it relates to unsupervised narrow learning. So personal assistant apps with basic voice Q&A, chatbots applying this pretty state-of-the-art, but they do exist and they're out there. Complex classification, for example, video segmented search. This is something that we do at Datum. We also do chatbots. Product recommendation based on hidden customer preferences. The key word here is hidden. It's customer preferences that not even the customer knows. Then you have identification of hidden biases from forecasting data and input. There's a thing about big data that is extremely dangerous, especially as it relates to data scientists and people who do analytics, which is this phenomenon that happened related to big data that in the era of big data, you can actually prove anything. Like, there's something called confirmation bias. So who here actually underlines the books that they read? Raise your hand. Okay. So the people who actually underline the book that they read, they usually, not every, they're usually doing confirmation bias. They're basically selecting the stuff that they find that confirms whatever they believe in the first place. And the issue about big data is they can prove anything. Like you can Google, Obama was the Antichrist. And you have plenty of evidence there. So one of the first things that kind of went problematic with big data is that you suddenly get the executives, the decision makers, this big data tool, and they just use it to confirm whatever biases they originally had. The cool thing about machine learning is that there is no bias, unless the data is biased, of course. But it tends to be quite brutal on the type of things that it finds. So as data scientists, you definitely want to use machine learning as part of it. Then, of course, you have other applications, which, real relation, clinical diagnosis. There's already algorithms out there that are being the best kind of conditions, for instance, in and I think that's going to be much trickier is stuff like sarcasm, nuance, articulations, and meeting contextual forecasters that are using several domains. The thing about humans is that they tend to be bad at specifics, but they tend to be like fairly good at generals, and especially cross-domain. That's the thing. That's the reason we still need humans around, because they know a lot of stuff from other areas. And you're not going to have an AI system that is able to do that anytime soon. So AI is absolutely ready for deployment on select activities. That's a fact. So this is supposed to be Andrew New, but it looks nothing like you guys. So sorry. If you don't know who Andrew New is, please Google him. Please Google him. Very big deal. By the way, we might actually bring Andrew someday. Yeah. Right? Yeah, we'll see. I won't show him this picture. But yeah, we're trying. Camille's trying. So Andrew's a genius at this, and he's really working lately on the idea that AI is the new electricity. And he postulates a series of targets for you on what is really targetable regarding AI. And this is extremely important for us that we're not the C-level guys. And sometimes the C-level guys, they come to us with genius ideas of what exactly is that they expect that AI can do, and it's like, okay, boss, that can't really. So we need to be able to explain this, because sometimes our expectations are kind of crazy. But here's the deal. Not all organizational activities are suitable for AI under today's very narrow paradigm. So the key here is to select processes, Andrew says, that take a set of unambiguous inputs and produces response. It's unambiguous, And then basically you map organizational processes that are repetitive, and that you happen to have a lot of tagged data available. The thing with legacy database systems is that people are getting rid of data, or they're storing it in some kind of warehouse where the data is not accessible anymore, because they just can't scale up the data. They're actually losing most of the potential training libraries for their own thing. And a lot of companies and a lot of organizations, a lot of governments, they kind of give up, and they kind of say, well, I'm never going to have the algorithm that Google has. And the fact of the matter is, we all have the algorithm that Google has. The only difference is they have the data. But then you see organizations producing this amazing amount of data that is related to their domain, and they're just storing it somewhere, or not even storing it, or get rid of it. Like, what a waste, right? So the second you start actually handling your transaction of data, then you find yourself with this very particular source of wealth. It's very exciting when you see it. And the way you see it again is to, take a look at all the repetitive processes, and then, look for the tagged data. You guys are engineers, you guys are DBAs, you guys know what you're talking about this. I really suggest to all professionals, don't take the approach of just buying a system from somewhere and saying it has AI. Man, it has AI, but it doesn't have your AI. It doesn't have if you're buying an AI system that was trained with, for instance, if you're a bank and you're buying an AI system that is from somebody else's data, then maybe that's going to be from purchasers from the UK, which are going to behave completely different from the Saudi purchases. So you have a lot of companies there that are using the same algorithms that you have availability to, and they're just using somebody else's data, and then they adapt it, and all surprise, it doesn't work that way. So whose responsibility is it to make this data actionable? It's actually DBAs, data scientists, data analytics. So let's look at examples of this. Whoa, sorry. So input, picture or video, what you just saw. This has a very specific input, picture. Has a very specific response, 0, 1. Is this a human face or is it not a human face? And what is the training library to that? How do we train that? Yeah, so we just get a whole bunch of pictures and we draw squares over the faces and then, boom, it's done. So you know that the first couple of neural networks out there that recognize faces were actually racist? Why? Yeah, training. Just, it had very specific Anglo-Saxon type of, folks there. Yeah, it's absolutely true. Yep, and still happens, by the way. I've worked on quite a bit in computer vision in the MENA region, and let me tell you, some problems in computer vision regarding tagging, especially women, is quite tricky for obvious reasons. It's necessarily possible, but you need to get the right amount of training there. Loan applications is a very good example of this. Now, loan applications, like, you have companies out there that are selling AI systems to determine loan application or not, and they're using certain, ways to determine that, not on the bank data here, but somebody else's data, and they don't actually work because behaviors of loan are completely different in KSA than they would be in the UK or in the USA. They're completely different. It's different, matrix. In the USA, you have this stuff called Chapter 11. Here, you're like, if you're broke, you're gone. It's, it's different cultures, different way that people engage into loan repayment. So the rules are not the same. And what I fear most is that you see a lot of companies promoting their AI, but they're promoting AI without a deep understanding of what is the data that this is, powering the thing. And that really scares me a little bit. And the example is just loan approvals. It's a fairly simple problem. You just do a query, show me all the loan approvals you've done before, based on, humans. Let's get this multidimensional data, let's model it, and boom, you're on. There you go. It's done. And it's an AI system. And just, call it something cool. And you're done, you're there. Translation. Translation is working beautifully with deep learning networks. That's something that's actually getting quite better lately. Now, what's not going to happen? You're not going to be able to get an AI that it's going to be able to exhibit human-like emotions or quirks. But how much attention there is to that? I mean, look at Sophia again. It's all about emotions and quirks and, things she does. It does, I should say. That's not AI. That's a poor representation of what AI means. Social learning is not going to happen in AI, not for a while at least. And then context. That's the thing that humans are really good at, understanding context. This is the reason we still need consultants. Because, they understand context. Now I'll share all this video presentation as well with you. So just drop in an email. Last point 4 is related to adoption. This is really more about technical feasibility. Because, whenever you manage to convince your bosses, and Andrew Davis is going to have a beautiful presentation tomorrow about setting up an ask to your supervisors on, hey, let's do an AI project. So yeah, that's going to be fun tomorrow. So make sure that you don't miss it. But I'll tell you right now, it's much more than technical feasibility. I mean, the technical feasibility is just.
How many times have you been?
Okay. So this is a true story, what I'm going to show here. And this story is not, this is based on a true story, happened to a customer of ours. And it's not really about AI, it's about data science, but the application is the same. So I just want to, share the story and you tell me if it rings a bell or not.
How many times have you been made a promise that they have later broken? Like that time you waited for something you very much wished for, but never arrived? Or like that other time when your illusion crumbled just before your eyes? An analyst at a large financial company receives an email from his boss. The president wants to know if there is a statistical correlation between job losses and non-payment of credit cards. I need the answer immediately. A meeting is convened with managers of various departments. The tasks are assigned and the schedule is tight. A project is born. A programmer will have to write lines of code for the analyst to get the correct information and make the necessary calculations. The question must be translated into the language of database. Hopefully, the DBA does it soon. The SQL does not yield the correct result. Repeat again. The IT department collects information. The team is still waiting for the IT people. The VP calls. By company policy, systems cannot share information without filling the format XRF589. IT finally finds the information. In which format do they want it? Wrong format, start again. No space? We'll need a new disk. That purchase request is not properly filled. Blue screen of death. The IT department buys a super machine. Now you need to install it. The information is already outdated. Ask for the query again. We'll need more hours from the programmer. The original programmer is on vacation and no one understands his code? Help! After nearly 2 months and hundreds of hours devoted to the project, there is still nothing to show to the president. The analyst finally gets an answer. In fact, there is a statistical correlation between job losses and non-payment of credit cards. The analyst did his job. It's not his fault that the disk ran out of space, that it took so much for the purchasing department to do its job, nor that the data model was not ready. But it does not matter. Answering the question to the president took 50 days, and it seems that this is his fault. The analyst does not want to go through all
This probably never happened to any of us, right? So let's look at the, I love this, by the way. I use it in every single one of my presentations. It's the Gartner Analytics Value Escalator. It's beautiful. And it's beautiful because when we speak with a lot of customers, with a lot of partners that are working with their customers. Usually you have the CEO or something that's doing this. Going like, I want prediction. I want prescription, right? And what this graph tells you is that, well, you need a couple of things before that. You need a couple of capacities. So what are these capacities? And take a look at X, which is the difficulty, Y, which is value. So the more you go here, the more difficult you're gonna get, the more value you can be able to extract, right? So, and also what this tells you is you cannot do this, you cannot do this, you cannot do this without doing this. So you need to jump it. So when you have a requirement like this, the first thing you have to figure out is, okay, do we have a database that is able to tell us what happened? Like, do you even know, right? That's number one. When you have that, then you have to work on the next scale of analytics, which is diagnostic, which is, okay, why did something happen? Now, there's a lot of people there, a lot of experts that are trying to tell our bosses that what happened is this, but they have no data to back it up, right? It's just an opinion. Very common. So, why did it happen? Diagnostic, we work on that. And then you actually work on prediction, which is trying to say what's going to happen in the future. And then finally, but only finally, after you've gone through this painstaking process of figuring out your infrastructure, and we're going to talk about infrastructure tomorrow, but I'll tell you right away, it's countries. The infrastructure here to get from here to here, you need to set it up in such a way that you actually can do this. So beware of any project that is brought to you where they want prescription, and you go like, okay, where's your data? And they go like, I have an Excel somewhere. Beware, run as quickly as possible. So again, descriptive, what happened? Diagnostic, why did it happen? Predictive, what will happen? And last, prescriptive, how can we make it happen? I'll tell you what tools do we use It's not necessarily the tools you would need to do, but then descriptive and diagnostic, we basically would use Couchbase. And then on predictive, we start stuff with TensorFlow and PyTorch and this type of thing. And we provide consulting to system integrators, but also end customers on how to build these tools, and so on. But this is cool before you start, panicking and saying, well, okay, machine learning replaces everybody. No, actually, no. There's areas where you want machine type of analytics, and there's areas that you need human, basically because of the intuition, right? So, and what happened is basically a machine problem. I'm kind of oversimplifying this. So this is, don't quote me on this, but still. On description, you need a machine. On diagnostic, it is not the machine who's going to tell you why did something happen. It's actually going to be a human and his intuition. So you use stuff like dashboarding and ways to present the data in such a way that the human intuition can actually do its job. Prediction should be completely machine. Like whenever you see a human do prediction, just ignore them, because humans are horrible at predicting events, like absolutely horrible. Like you can build a regression line with just a simple formula and beat. You can just do Bayes' theorem and you beat any human analyst out there. It's that. I don't care if he's an expert on whatever. You can beat any of these guys very easily. But that's really a machine problem. Some people will contend it, but they're wrong. Sorry. And then last, it's prescription. Like, okay, how do we make something happen? That's actually a human problem. Too. So I'm about to finish here because I'm not going to give you the type of I'm not going to tell you, like I don't want to walk you, we'll do that a little bit tomorrow, but I don't want to walk you through the type of stuff they usually do with garments. I just want to make sure that you can recognize this. So there are specific types of garmental problems that are applicable and appropriate for AI applications. This is not necessarily the rule book, but it's something you look at, right? So if you're managing a large data set, and by definition, my definition of a large is that it doesn't fit in one server. That's a good definition. Yeah, it's just a rule of thumb. Where the data set is too large for employees to work with it efficiently, where you have internal and external data sets that can be combined, and that you have highly structured data of years of history. Like, look at the company's history, and you have a large data set, you have an opportunity for AI. Just figure it out. Just, find a way to get the data to talk. The other cool target that should be on your hit list is experts shortage. Whatever, this is one of the reasons that chatbots are very cool, because experts are still experts, but most of the questions that experts get are pretty basic. So you should keep the experts, doing the more complex stuff, and then you just allow the bot to handle the rest of it. So basic questions that can be answered, that where you free up time for the experts, that's something you want to work. Niche issues that can be learned to support experts in research, and then inquiry response times that are long due to insufficient support. Yes, sir. Yeah. Gives you a hit list.
Can you elaborate a little bit on the inquiry response times?
So basically, for instance, if you have a customer that's asking for one particular service and you don't have enough time to respond to that particular service, like chatbots, for example, you wanna calling a call center, which is a nightmare all over the world, right? If you actually look at the data within a call center, you're likely going to be able to offload that into a chatbot. So it's whenever you have a long queue of people, because there's just not enough people to support, that's a target for you in AI, because it immediately becomes a cool target. Tomorrow I'm actually going to give you examples of infrastructure in every one of these cases. That helps a lot. You have predictable scenarios. So whenever you have experts doing predictions, try to do it with an AI system. and you'll beat them. So find situations where it might be predictable based on historical data, because there's a lot of historical data. Find situations where prediction will help with time-sensitive responses, and where dimensionality of data is high, right? If you think about machine learning, Mark here, but machine learning is basically a way. I think we all done this, right? You have X and Y, you have a whole bunch of dots, and basically machine learning is just tracing a line that has the minimum error to the data points, right? You know, statistics 101. Okay, machine learning is just that, but it's just not 2 dimensions, but it's, you know, several hundreds of thousands of dimensions. So as addition, it's not going to be able to do that. Machine learning is going to do even better. So wherever you have dimensionality of data very high, and where the data, by the way, when the data was simplified, because that's one of the things about schema legacy database systems. Because you need to fit it on a table, resolution of the data is lost. Right? Does that make sense? Like, you know, I need to fit in this table, and it's telling me what, you know, this customer had for breakfast yesterday, but it's not on my table, damn it. So we just lose this data, you know? And if you're working in a company culture where the DBAs are just like, okay, ignore that data because it's not on my table, do a change in my table, then my entire Oracle system is going down, then it's probably time to consider NoSQL, you know? And so real data has very high level dimensionality. Data that ends up in the table has very low dimensionality because somebody just was trying to, you know, simplify his own life. Procedural. It's quite obvious. Anything that is repetitive by nature, anything where you have inputs and outputs that have a binary answer, yes, no. Is this a face or is it not a face? And anything that relates to training data that can be collected with relative ease. That's your target, okay? It's very sad when you see like guys in universities and so on, you know, really smart kids, and they know how to do it, and they go like, okay, we're gonna build a system that, I don't know, does whatever. And then they go like, where's the data? You know, start from the data. Start from the data. Just don't go out there and figure out you know what other people are doing, or just forget about that. That's irrelevant. Look at your data, and then you could go like, I might be able to predict this. Just always start with your data. Forget about what your competitors are doing. Forget about what we're doing. Forget about what IBM is doing. So forget about Sophia, the robot. Forget about these guys. Let them do what they're doing. They're very good companies, by the way. Well, not the Sophia one, but the rest of them, they're very good. Look at your data, man. Just, you know, look at your data. It's going to come to you. And you're going to find something that is a procedure that says, hey, I can automatize this. I can definitely do this. And then just build it. Diverse data is quite interesting too. Which is where you can, you know, I don't know, you know, get bank data and then combine it with social media, and it's like, holy crap, I got something new. It's like, it's actually quite easy to, and by the way, legacy systems are built like in separation, right? So you have like your CRM system and you have your whatever else system is on. And you know, you have this for years, and somebody tries to combine the data, and then, you know, magic happens. It's a very good opportunity for AI. So here's your mission. First part of our mission is go back to your, you know, whatever it is that you're doing on your day, and, you know, look at data in a new way. Look at data and like, I can automate this. By the way, I've been in Silicon Valley for 12 years. I lived in Palo Alto and the whole thing. Let me tell you something about Silicon Valley. These people are not as smart as everybody believes they are. They're just more risk averse. You know, they're just risk averse, and they look at stuff from a new point of view. And by the way, Saudi data AI problems are not going to be resolved by foreigners. Definitely not by Colombians, by the way. Yeah, it's going to be solved by Saudis. Because you understand your culture, you understand your data. So take a look at your data, just, you know, use it. And when you start grading that, you know, put that as part of your mission as DBAs, and you're not only worried about, you know, the database not falling down and so on, then, you know, it's quite refreshing. If the data is there, you can get very simply, and we can teach you how to do it, simple stuff, simple architecture in Keras, and just run it through, and it might work. It might not work, but at least you tried. So it really is all about you guys. That's all I got. So I don't know if there's any questions. There is a little bit late. I apologize for that. We'll be around tomorrow. I'm very responsive to the email. Usually I respond to between under 24 hours, 48 hours at the most. So please go ahead. And we're going to help. Tomorrow there's really cool presentations. We have one on from Dr. Haji and infrastructure, and a little bit more technical. It's very interesting to take a look. We have from Andrew an approach a little bit more how to get projects going on AI. So this is going to give you some very cool tools. And we have Sebastian, the guy with the Vinci beard, that he will give you a very good walkthrough on how NoSQL and AI play in the same mix. It's going to give you a very cool set of tools. So please join us tomorrow. And tomorrow we're actually going to be downstairs. So there's plenty more space. So we're going to do very cool budget. Because that'll be tonight. And you got people that might be of interest, we're going over. More the merrier. Okay.
Well, thank you so much for coming. Tomorrow we start at 9:20. So if you can be here a bit earlier, then that's perfect. Just like Cesar said, we're gonna be downstairs in the big room. Third floor, yes, downstairs. Please invite anyone, invite your friends. We're open for tomorrow. Thank you. Thank you, have a good day.
You've been given your job, which is to turn on the TVs.